In this video, we're going to talk about the oscillator and shaper modules in Kontour. They really constitute the heart of the synth engine. In order to do so, we're going to take a default sound here in the Nonlinear Labs bank. This sound has just one single oscillator active. Oscillator A is going into the mix here. And we have no effects and really nothing else happening. So we just have a sine wave coming out here. So what I'm going to do is I'm going to set up the sustain so that we have a constant sound going on here. I've also just added an oscilloscope so you can see as well as hear what I'm playing. This will be useful to see what's happening to the waveform as I make changes. I'll show you how to add an oscilloscope in Reactor in a future tutorial. Next to amplitude, probably the most important parameter of an oscillator, is pitch. Pitch can be changed right here with Kontour. So if I play a middle C, C3 on my keyboard, that's exactly what Kontour is going to produce, but I can transpose it right here. So here I am 2 octaves lower, and I double click and I get back to middle C, or MIDI note 60. Now this can be thought of as a relative value, so if I go 12 semitones above, that's an octave, so I get my octave. And double click to get back to MIDI note 60. In addition, we have key tracking right here. So this means there's a one-to-one relationship between the different octaves I play on my MIDI keyboard and what Kontour is going to produce for me. If I take this down to 0, it means this note is exactly what Kontour is going to play, no matter what I play on my MIDI keyboard. So I'm playing a lot of different notes on my MIDI keyboard, but just getting C3 or MIDI note 60. I can also shoot this up to something like 500 and play a quarter tone scale. There we go. And in addition, I can put it back up to 1-to-1 and maybe make a stretching sound, a little bit of a stretch octave. And to do that, I'm going to add a little bit of self-modulation. I'll talk about this in a second. And you can hear that beating between the octaves. And you can actually see it as well. And if I turn that up, it starts to sound out of tune. But just a little bit goes a long way to make your sound a little bit more lively. I just mentioned self-modulation, but what I mean is that the output of oscillator A is actually being used to modulate its own phase. It's called phase modulation, but most people refer to this as frequency modulation, or FM. And it has a very long history going back to the Yamaha DX7 synthesizer, probably the most famous, and used today in a lot of software synthesizers, including Native Instruments FM8. Let's put this back to the default value here, so we just have a sine wave. And as I turn the knob here, I'm increasing the amount of self-modulation, and we're tending towards a sawtooth sound and a sawtooth form here. And what's interesting is, like a lot of knobs and faders here in Kontour, it's bipolar. So we're going to reverse the phase of the self-modulation. And you see a reverse sawtooth type waveform, and you can hear, it sounds the same actually, but when we combine this together with other waveforms in the mix, for example, there'll be some phase cancellations and a lot of interesting things can happen. Another way to enrich the spectral content of your sound with Kontour is to use one of the shapers. And you can see that oscillator A and oscillator B have their own shapers here in the block diagram. Let's go back to the user interface. Probably the two most important parameters of the shaper are drive and mix. Let's just put the drive down to nothing, to 0 here, and we'll play and add in the shaper. We don't hear a lot going on here, just a little bit of harmonic content. But as we add the drive, we can see and hear some distortion happening and some foldback as well. So we're getting some more harmonic content here. And if we move it all the way up, we get a lot of harmonics going on here that give us a very rich spectral content. The fold tells us how much we're folding over and down after the original peak here. And the asymmetry makes it so that one side is a little bit different than the other side. So you can see that a little bit better here, where my bottom's nearly smooth and the top has this big dip in it. Now if I turn the fold all the way down as well, turn up the drive, I get something very close to a square wave. So without any different waveform generators, just using a sine wave generator, I'm able to create a sawtooth-like wave, a sine wave obviously, and a square wave with a lot of different variations in between them. Up to now, we've been just using one oscillator, oscillator A, that's going into the mixer right here. But we can also add oscillator B. Now, you don't hear a big difference because they're at the same pitch, but I can obviously have them going an octave apart here. In addition to self-modulation, which we previously talked about, I can also have oscillator B, for example, modulate oscillator A. So in this case, phase modulation from oscillator B comes right in here. And of course I can have oscillator A still self-modulating itself. And I can create a cross-modulation where oscillator A is also going to be modulating oscillator B. And now it's in a different polarity, and you can see that, and hear, that there's quite a bit of harmonic content that we've added here. This becomes quite interesting when we change the relationships between the two. We have an octave here, which is a 2-to-1 relationship, a harmonic relationship, but we'll get a very bellish or metallic sound or even percussive type sounds if we change this relationship to be a non-harmonic one. Or we can also just barely tune them apart. I'm going to take this back down to 48, so it's an octave lower. But if I detune it slightly, just 5 cents off, we get kind of a beating sort of sound with the oscillators. So there's a lot you can do with the cross modulation here. And in addition, I can add the shaper into the cross modulation. Let's set this back to the default values here so we have more of a pure sound. And here we have our sine waves here. And I'm going to add phase modulation from B here with the shaper of B coming in here as well. So this is the shaped modulating oscillator, modulating oscillator A now from B. And of course I can do the same thing with the self-modulation. The last part of the oscillator shaper modules we're going to look at concerns ring modulation. To get a good idea of how this is working in the signal flow, let's look at the block diagram. In Kontour, ring modulation takes place after the envelopes. You can control that here with these two faders, and what's happening actually is the two signals are being multiplied together. The resulting signal contains the sums and differences of the original signals. To illustrate that, let's go back to our user interface. I now have the output of both oscillators routed into the mix. When I play, you just hear them added together. But watch and listen what happens when I increase the ring modulation. We hear an octave, which is the sum of the two frequencies that we're playing. The difference would be 0 because they're both the same. But if I change this relationship, you can clearly hear two signals as I'm playing. Now, this becomes very interesting when we start to increase the modulation, the phase modulation of the oscillators. And I get much more inharmonic sounds. Or if I set them an octave apart, clearly a lot more harmonic content. Another thing we can do with the ring modulation in Kontour is take one of the signals and move it way down to a very low frequency area. And this says -10, a MIDI note, but that represents a very low frequency below the hearing range. And if I put the key tracking to 0, I can play a chord here and move from the actual kind of tremolo sound, a low frequency, an LFO type effect, to a real amplitude modulation or ring modulation effect. And of course, through some fun modulation here, I can really achieve some very rich sounds coming through. This concludes our video on the oscillator and shaper modules. In our next video, we're going to look at the comb filter and the state variable filter.